Today we're going to talk about seismic waves. So I've got here, you've got P waves and S waves. We're going to talk about the sizes of those and how to draw them on a seismograph. You will have a packet today to work on for drawing those. So P waves are going to be really low amplitude and high frequency. And then S waves are going to be really high amplitude, high frequency. So kind of like this. They're going to be a little larger. So on your paper that is going to be, or your packet that's going to be passed out today, there's going to be these bars. And on the bars, so I'm erasing all that, it's going to look just like this. And on these bars, each one of these is a seismograph. And it tells you at the top that all the earthquakes are going to start at 9 o'clock. So for your time spot, all of your waves are going to start right there at 9 o'clock. And then it tells you the duration or the difference in time. So what that means is how long it took from the P waves to start to the S waves to start. And so on the example that's done on your packet, 3 minutes and 30 seconds. So if it starts at 9:03, the P waves are going to go and keep on going until 9:03, 30 seconds, and then the S waves start. And then it gives you your amplitudes up here at the top. Your P waves here are going to have 5, and then the S waves are going to have 20. Now, for each of the examples, you're going to have to be looking at those different factors and things. So on this one here, it still starts at 9 o'clock, but it says the difference in time is 2 minutes. The P wave amplitude is 10 millimeters, and the S wave amplitude is 15. There's a little grid right here that you can use to help determine the amplitude. I'll go ahead and draw this one out. So our start time is 9 o'clock. Try to make it look like your paper. And it says that the difference in wave time is 2 minutes. For myself, I'm going to put little hash marks to show the minutes. So that way you can see them too. And my amplitude is 5. And we're just going to guesstimate on that because I don't have the paper on this whiteboard. A little grid. Okay, so here's kind of what you're gonna have, but yours has more lines and is easier to follow. Okay, so P waves are gonna be an amplitude of 10 millimeters. S waves are an amplitude of 15 millimeters, and difference in time is 2 minutes. So my P waves are gonna go. Oop, that's way too small. Let's try this again. You're definitely going to want to use a pencil or something that you can erase on this. Okay, so P waves are 10 millimeters. So I'm going to try to follow my guide so that way they're about 10 millimeters. Okay, so there's my P waves. If you want to mark a P on top, you can, just so that way you can indicate your primary waves. Okay, don't forget P waves is primary, and then S waves are secondary, and they come second. Okay, so now our S waves are 15 millimeters, which kind of don't follow the trend. They're going to be a little larger, and that's okay. So at 9:02 is when our S waves start, and you should be able to see a difference in amplitude. And then I'm done. And then if you want, you can put an S here. So that's what number 1 would look like on your paper. Well, close to it. Now, on your example, you notice that there's these gaps here, okay? That's just a line to indicate that this sort of frequency would continue to that time point. Now, I would like for you to draw it like this, so that way your waves connect. I do not want to see laziness. We're drawing waves and we're just, Okay, now we're drawing again. We've got a couple and Look at the difference from here to here. This is lazy, this is accurate. So make sure we're not doing this and you're drawing all the waves. You guys, you're just drawing squiggles. Just think of it that way, okay? So that is how to sketch a seismograph. It'll also be called in the book as a seismogram. Both of those are interchangeable words, okay? So it does go through a couple of options all the way through number 6. Number 7 says which seismograph station 1 through 6, so problem number 1 through 6 was closest to the earthquake. So if it's going to be close to the earthquake, let's say I've got an earthquake here in OKC. And these waves are traveling and traveling. And I have a station over in Tulsa. I've got one in St. Louis. And I've got one in, we'll just say, Davis. This is all hypothetical, okay? So if I've got these stations here, St. Louis, Tulsa, and Davis, and the earthquake happened in Oklahoma City, which seismograph station would be the closest? The one from Davis. And the way you would tell that is how much time it took for the waves to travel. So since Davis is a lot closer to Oklahoma City, it should be a really small amount of time. For St. Louis, it's going to be furthest from the earthquake epicenter, so it's going to be a longer amount of time. That's all that question is asking. All right, so I'm going to go ahead and turn the page and walk you through the next portion. So this is measuring magnitude. It looks a little daunting. It's fine. Don't worry. Okay. All you're going to do is you're going to plug in the information that's given, and you're going to plot points on the lines and connect the dots. So I'll draw a little scenario on my whiteboard here. So you're going to have the distance, the magnitude, and amplitude. And make sure you're reading your units on this, because it's not gonna, some of them are, actually all of them tell you this stuff. Yes, just be careful not switching, or you don't want to switch up your columns. So you're gonna have different hash marks on each one with different units of measurement. And what it'll give you is it'll give you 2 pieces of information, and you're trying to find the third piece, which in this case will be the magnitude. So I've got these lines kind of like what you got on your paper. Okay. For example number 1, it says wave amplitude was 180 millimeters. So I'm going to pretend that dot is there. So I'd plot a dot on 180, and you have to read the scales carefully. And then the distance to the epicenter was 540 kilometers. So same thing, kind of follow your grids there because they're all different. Okay, so now I've got 2 dots, and it's asking me to find magnitude. So for magnitude, you're just going to connect the dots. go ahead and make your distance to the epicenter at 500 kilometers. So write that on your paper. 500 kilometers is the distance to the epicenter. When you're done, just check over your papers to make sure you match them, kind of like how this video said, and then go ahead and staple that packet into your notebook. Make sure your table of contents is updated, and then be ready for your next assignment.